Hello, everyone. Thank you very much for attending my session, and thank you very much, React Day Berlin, for having me here today. So today I want to talk about testing and what I think is very important, which is principles. First of all, I want to introduce myself. And let me introduce myself. My name is Lobera, and I love a lot of things. I love JavaScript. That's why actually I like to introduce myself using JavaScript. Of course, I love React, GraphQL, and other stuff. And I have other passions apart from coding, like dancing and yeah, my girlfriend. Not in this particular order, right? Where's the camera? Not in this particular order, Anna. So I work for React GraphQL Academy, and I like to code, teach, and make decisions. And that's my Twitter if you want to connect later on. Another thing about me, I do love to remove code. That's one of my passions as well. So I think actually developers, we should be paid to remove code while delivering all the features that we should. And I would like to start telling you a little secret about myself. I'm a senior software engineer, and I'm extremely good. I'm really, 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 really good at writing bad code on the first try. And I think I'm not alone. Adios Mani said, first do it, then do it right, then do it better. And it's actually not about in which iteration you are and how many times you do it. It's all about the iteration in itself, being able to do it again. Please, show of hands if you can relate to that. If you are like me, like you cannot do it perfect the first time you try. Great, I think it's most everyone. Why is it so hard? Like, why is it so difficult to do it perfect the first time? Is it because of us? Is something inherent to us developers? Like, is there anything wrong? I think it's not. I think it's because it's the nature of our job. Software development, it's a complex process. The process of developing software is complex. And I'm going to define complexity in the context of this talk as the unknown unknowns. All those things that we don't know yet, right? And there's going to be a lot of things that we won't know. Just because things change, just because requirements change, just because technology changes, team changes, market changes, so there's going to be a lot of complexity as well. We can also, in other words, say it's like the relationship between cause and effect cannot be deduced, only can be deduced in retrospect. So it's impossible we do it right the first time. So it seems to me that the more tests we write, the more we can iterate. So my goal today is to foster critical thinking and to explore some testing principles that work for me. But please, don't just follow what I say, and I encourage you to, be critic and try your own ideas. And what works for me maybe doesn't work for you. So first, who does benefit of writing tests? I think clearly users, they're going to be happier if we write tests because they're going to be less bugs. There's another segment that is really important, and I think it's product owners, managers, stakeholders, etc. Because sometimes they don't understand. They want us to write more code and go faster, but in the long term, it's going to be good. If we have tests, if we automate our tests, we'll be able to write more features, so they're going to be happier. Other developers, your colleagues, you can document code by writing tests, even for your future self. Think of your colleagues, your code is going to be easy to be understood. So happier colleagues, that's great. And let me be a bit selfish, last but not least, myself and yourself, right? Code refactoring, we've been hearing about code refactoring in this conference. I like that. I also agree. It makes me really happy. When I refactor my code, I feel that like that sense of, wow, I look backwards and I say, wow, this is really cool now. And actually, I could improve it. If I can go back and make it better, it's a huge satisfaction. So writing tests can make happier everyone. There's a but always. I wonder, okay, how many tests do I write? Which type of test do I write? So what I do is I follow two guiding principles. One is called refactoring, and the other one is degree of confidence. Code refactoring is when we change how the code works, but we don't change what the code does, right? And degree of confidence is how confident you are that the code works the way it is intended. I also like to describe it as how confident you are that on a Friday afternoon you can deploy code before you go home. That's very confident, right? So, just saying. So, how many tests should we write? So I want to maximize my confidence, but I want to minimize the cost of it. And I've seen some talks and read articles about that sweet spot. Is that place that maximizes that? Is that sweet spot? And I've been looking for it. And I couldn't find it, so sorry, I don't have the answer. I even wonder, is there a sweet spot? Code coverage, does code coverage measure that? Could also say, when I ask this question, I get back like, yeah, we do like 90% code coverage, so it's good. And is that number enough? Like, first thing is like the right metric? Does it measure refactoring with code coverage? I'm not sure about it. So I did some research. I looked at Create React app, and they give us this test. And I thought, is this good? I mean, it makes sure that the app renders without crashing, which I think users value. I think it's important. And it definitely increases the code coverage because you are rendering your application. Then I thought I use Gatsby a lot, and then I thought, is this worth if I do this in Gatsby? And I think the answer, it doesn't, because actually a Gatsby will crash, and you won't have basically a website to deploy if it doesn't render. So writing this test doesn't give you doesn't give me any confidence. So, but it actually increases the code coverage. Then should I just write this test to increase my code coverage in a Gatsby website? Should I render all my components? And I think this can encourage some vanity metrics, right? Having the wrong APIs. I've been speaking with companies and developers, and sometimes they set goals like, we need to get 90% code coverage or 100% code coverage. And we developers, we like challenges. If you tell me you need to get 100% code coverage, I'll make it. But I can also find ways to just get it without adding much value. So what is actually a vanity metric is a metric that you can manipulate to get some result, but maybe it doesn't give us the right outcome we expect. So I thought about actually comparing that code coverage over time with other KPIs. And I was correlating in some projects, and I've seen this is like I kind of made it up. But I've seen this from different projects. So what I mean is it's not like data that I rigorously capture from a project. But I see a tendency that if the code coverage starts going down, then the bugs can go up. And that's an indication. That's something interesting. That gives me real information, regardless of the number of bugs and the code coverage. I see a correlation. At the same time, I can also see if I can compare performance. In this case, I can see that the code coverage stays the same. Right? I can push my developers and say, we're going to build more and more features. And we keep the code coverage the same, but maybe, and then we are like, oh, well, we are like not pushing too much. But maybe the performance is going down, right? And so we are also paying some price for that. By the way, there are tools that you can use to automate these things. Is something that was just released a week ago, and I think it's really, really cool. It's adding Lighthouse to your CI. You can actually get a lot of information in terms of performance. Going back to this, is that in this case the sweet spot here? And so what is the number? What is the code coverage? And to be honest, I don't care. For me, what is important is these tendencies. I think going better or we are getting worse. So I actually stopped looking for that sweet spot. So those are my metrics. Those are my guiding principles. And I encourage you to know yours and to critique mine and to be, try to find something that works for your context and for your team. Another thing that I wonder is what type of test should I write? Different experts say different things. This person works at Facebook and said last year he likes to write the same amount of integration units and end-to-end tests. Another person said last year as well, you should write more integration tests. And there is this idea, this author says that we should write actually more unit tests than integration tests. So what should I do? I also wonder which tools should I use. Should I use, I'm a React developer, should I use Enzyme? Like apparently I'm going to be a very bad developer if I do that. Should I use React testing library? And I was in a Slack channel, like many of us, we are in many Slack channels, and there was one of, we were a few developers here. And so one developer, which by the way, these are not going to be the real names. I thought for privacy, I changed the names. So Watermelon came up with this question, and okay, fair enough, he had this question. So Mushroom gave some answer, and then Spinach, I was observing all this. Spinach said, run away from Enzyme. That's the problem. And then Watermelon says, oh, this shows that. And for me, I look at that, it's trying to be called. For me, that's an implementation detail. To me, that was like a wrong thing. So then I jump in, I made a bad joke, and then I said, look, have you read this article? This article says, you should not check implementation details. You should minimize that. It's actually a very interesting article. I recommend you to read that. I think the first time I read the article, it was 10 minutes. Eric Elliott keeps adding things, so I would read it soon before it gets like 30 minutes or an hour. But it's really interesting. But long story short, it says mocking is a code smell. It doesn't say it's bad. It's a code smell. Why? Because by definition, when you mock something, you know something. Right? So, and then every time you know something, then you are looking at an implementation detail. So we know our applications have side effects, and we need to talk to APIs, and we need those things, and we'll need to mock those things. But probably too much is an indication that we are not doing something good, and we should try, therefore, to minimize that. So, talk is cheap. Show me some code. So how much time do I have? Yeah, I have a lot of time. So I'm going to show you an application. Let's first run the application. So you can see what we are going to be testing. So this is actually an application I use in my training. When we teach React, we thought like, I don't know, building Facebook Messenger, kind of to be in the context. And so one feature that I thought could be interesting to test is the ability to send a message. So in this application, I don't have many friends, but actually I have one friend. I think it's the person you want to have on the stage with you if you're talking about testing. So actually, I asked him a few questions before, and I was not sure about doing some live coding. He gave me some advice, maybe. Not sure. Anyway, I'm going to go for that. I think he's... are you still there? I think he's not, probably because he's in the States, the time difference, and maybe the local host also has something to do with that. But I was able to send a message according to the UI. So I'm happy. I sent a message. In my mind, he's sleeping. So let's test that. So what can I do? I have some tests here I'm running. Yep. So the first test is a unit test, right? So I thought, let's try to write a unit test. Some people say unit tests are good, so I tried to do that. So because you have a note here. Let's define what a unit is. What is a unit? So I think a unit is something relative, like what a unit is. So to keep it simple for this context, I'll say that a unit is a component. right? One component, regardless of the size, is going to be a unit. So I think the most relevant component to test this is these messages components, right? You have a button, you click here, then invokes this other function that calls an API, does this receive message, which is some Redux stuff. Okay, so I think that is the closest one. So I could, because I want to write a unit test, I'm going to shallow. I'm not saying this is what we should do. I'm just saying I want to write a unit test. So that's the best component, I think, for the job. I'm going to shallow because I don't want to render many other components and so dependencies. I provide the props it needs. I add some text. By the way, I'm using Enzyme. I click on the button, and then I need to check. That's the most interesting part. There are normally 3 parts in a test. You set the things up, then you execute some code, and then you expect that the code does what it was intended, right? So how do I know my code works? Like, how do I know it works? I don't have many things I can do. So I can go and say, I can ask questions to those inner pieces inside, like the API. API, did someone call you? Yes. Did you get this message? Yes. So it kind of gives me some confidence, right? If I remove this, my test should break. So that gives me some confidence. What if I remove this? It gives me some error. So, okay, it gives me certain confidence. Let's get this back. Gives me certain confidence. But to increase my confidence, I need to add details. I need to say, hey, did you do this? Did you do that? Like, I need to specify things. Are you doing this and that? And that's because of the nature of the test. The unit test, I have some component, and I have a simple surface that I can evaluate if it's working. So what I see is, thinking of that article that I was sending my colleague, according to the article, when you check for implementation details, so you know what the code is doing, you have like a white box. And the opposite, the black box, is you don't know any implementation details. And so to me, this looks quite on the kind of white box side, because I know implementation details. I know there is an API. I know you have this receive message. That will send this sort of a shape. So I know details. So my confidence is sort of okay, but what if I remove Redux? Is my test going to work if I remove Redux? If I decide to put my messages into a reducer here, hook reduce, I won't need this. Therefore, my test will break. So confidence, so. Refactoring, really bad, because I'm checking a lot of implementation details. So the next thing I could do, I have 10 minutes left, so I'm going to try to do some live coding, so it's going to be more fun. So if I make mistakes, you will enjoy. If I don't make mistakes, I will enjoy. So I'm going to start by copy-paste, this thing that we all do. And so I'm going to write an integration test. What's an integration test? It's going to test more than one unit. So we need at least 2. And we put them together, and we see if the interaction is good. So what am I going to change here? So now what I'm going to change is, I don't want to test these messages, because that's a unit. I want to test a few components that they integrate together. So if I go to these definitions, this looks like a good candidate. I'm going to compose all this. And this is what I'm going to test. So I will replace this with this. Then do I need to provide this receive message now? I don't, because that's Mr. Redux doing that. So I don't need to do. That's one less thing. What about the API? I didn't say anything about the API, but the API is a prop. Every time I show this to people, they actually feel like, oh, what is that? Or like, oh, they don't like it, or they actually find it useful. Because you think like you're changing your code. So to facilitate testing, that's wrong. I mean, maybe that's wrong, but the alternative is I need to use some mock that it will, change the require. It's gonna do some magic, and this doesn't change doesn't affect the performance of my component. This technique is called dependency injection, right? Instead of importing something and using and hard coding that in my code, I'm gonna have a mechanism for changing that, right? Dependency injection. I know Angular does a lot of that, but we don't have a mechanism embedded in our React, but we can leverage that. So, do I need to provide the API? Yes, I still have that dependency in my integration test. So if I run this, I should get a bunch of errors. Couldn't find a store. Yes, our Redux needs a store. So I'm going to do something which might not be the best thing, but I'm just going to do it. And I'm going to create a store. I have this little file that can help me create a store. So bear with me. I'm doing things that I don't mean that's what I would do. We're just building up to evaluate and compare some approaches. So now I need to provide my store. Are you happy? Simulate didn't work. Okay, we are going to use the input. Actually, I'm going to mount. Why do I mount? Because I want to test different components, not only one. Otherwise, I would only be rendering this. Connect. So let's see, I got a new error, this act, which is going to help us apparently. So the message is actually quite nice. Are you changing some state? Wrap it with an act. Let's do that. Where am I changing the state? Here. I'm also changing it here. I also, because my code is asynchronous, my API is, it returns a promise that's asynchronous, so I will need to wrap this with some asynchronous code, and now hopefully we're back on track. Great, so now I can remove this. So what do I test? Now this interesting thing. Do I want to go to that and to have been called and look at those details? What would I do if I was doing some manual testing? I would be, clicking here, sending a message, and see if the message is on the screen. So we can do that in an integration test. So I can go and say, I expect that my wrapper. Let's find. Okay, since we are using Enzyme, I'm gonna look for a message, because I'm not saying this is the right thing to do, but Enzyme let us do so many things that let's explore that. So I have this message component here. So the list of messages is made of message. And so what I'm gonna do now is I'm gonna look for those, and I could say that the length actually should be 1 at some point. Okay, I always make the same mistake. I thought I was not going to make it today. I always forget this wrapper update from Enzyme. I don't know why they don't update when you update the state, but we have to do it. Okay, good. I could also do, I don't know, before I send the message, I could say to be 0. I could say, because I know there's only one node, I just can say, give me the text, and to be to this. I think we should probably do something like a random message, something better, random. Yeah. Let's get a random message. to make it a little bit more robust, maybe, predictable. So I expect that this will be this random message. Coolio. So now let's compare. Does it feel, if I remove Redux, is this more black box or white box? Is this actually a black box? I think it's not, because I got more closer to the dark side. We should try to be on the dark side. And it's not completely black because there are implementation details that I know. I still know there is an API, I know this Redux, but I know less details. And what if I remove Redux from my application? Will my test break? I have Redux here. Yes, it will break. So before I do some refactoring, let's go and compare it to an actual similar test with Enzyme, sorry, with React testing library, which I'm going to copy from some snippet that I have here. Actually, I have it here already. So if you compare one and the other one, they are not that different, right? So, you know, here for me the lesson is this Watermelon said later on the chat. You know, the problem is I cannot just change to React testing library. This company is using Enzyme. I cannot change that. But to me, the fundamental problem is you're still testing the wrong thing. Come on, like you can still Enzyme lets you do many things, but you can still do the right thing if you want, right? So, and then we could use React testing library, forget about the previous test, and then we will be happy we're using the right tool. But to me, it still is a fundamental problem. If I remove Redux from this application, does my test break? I mean, I have the store here, so wouldn't it be better if I remove the store from here? I can then use this component here, this root. I can wrap my root component. So my test is working, and this is better. So because now I could remove Redux from my application, and that's like kind of a big thing. You know, you remove Redux, and my test still works. Like, that's a big thing. And so you should try to write tests that maximize those guidelines that you set yourself. Because if I just think of, I'm going to use the right tool, which is, I don't know, React testing library, you can still do things, you can still improve things. And even if you're using the tool that might not be the right tool, Enzyme, you can still do the right thing. I could do the same in the previous one and wrap this with a root. So, that's can still know it thing work, just in case he's worried. Everything worked. So that's my talk for today, and I hope it encouraged you to go beyond the discussion of whatever is the tool, and try to understand why it's good. And try to apply those patterns, because there will be situations where we won't be able to choose the tool we want to use. But doing the right thing is always possible if you know what to do, and try to have some metrics to evaluate. And sometimes we say things like, "Oh, this code is elegant," or "This code is beautiful," and like why, right? So try to have some good metrics. Not much vanity metric, but metrics that make sense for you and your team. And happy refactoring. Thank you very much.